All right. Equations of lines. There are three types of equations of lines. Or three forms. There's the point slope form. Then there's the slope intercept form. The y equals mx plus b. Then there's the standard form. Ax plus by equals c. Where a, b, and c are integers, and a is positive. So you notice that the standard form, you have the a, x, and y on the same side, and it'll have some coefficient in front of them. Now, the reason this is the form, this is the way it should be done, not the way the book had it, is because, first thing, what do you need? What's the minimum information you need to get an equation of a line? To find an equation of a line, you need what? 2 points. If you have 2 points, if given 2 points, the first thing you have to do is find the slope. Yeah. Because it makes it easier if you know the slope and have 1 point. That's the information you need. Because if we have the slope and a point, then we can automatically start plugging in there and we're done. Because if you notice, look at our equations. There's a slope. There's a slope. So either way, if we're given 2 points, we have to find a slope anyway. But if we're given a point and a slope, then we just plug them in there. So if we're given 2 points, find the slope, choose either of the 2 points, and then find the equation of the line, the EOL. So before we go any further, let's see where these came from. All three of these are related to the same equation. They each have what involved? And the first two have what term in common? Slope. So if we look at the equation of a slope, and we have a general rule whenever we're solving for y, how do we get these guys alone? What do we have to get rid of? We have to get rid of this. How do we get rid of the bottom? How do you get rid of a denominator? Multiply by it. Multiply both sides by the denominator. So if I take the x2 minus x1, and multiply it to both sides, the x's cancel on this side. So remember what I said earlier. If you have 2 points, you find the slope. Once you find the slope, choose either of the 2 points. So we don't need an x1, y1, x2, y2. So forget these. The only point we're going to use is the x1, y1. Where x1, y1 is a point. So what's the name of this equation? Well, you don't have to go back and look at it. It's given a point and it has a slope. So therefore it's a point slope formula. They don't try to make these names tricky. It's just straight up what it is. Okay, so from the slope, we go to the point slope formula. So let's pretend our point is 3, 4. Our points and our slope is 5. So how would we write our equation if we're given this information? Y minus 4, because that's the y value. What's our slope? 5. X minus, what's our x value? As I said, the x1, y1 is a point. There's your point. So this is x1, that's y1. Just plug them in there. Okay, so that's now let's go to the next form, the slope intercept form. How do we do that? Solve for y. The next step, solve for y. What do we have to do first? We have to get rid of the parentheses first. So we distribute y minus 4. 5 times x is 5x. Positive times negative is negative. 5 times 3 is 15. Treat the numbers and the signs differently. We're solving for x. What do we have to get rid of now? The negative 4. How do we do that? Add 4 to both sides. y equals 5x. Negative 15 plus 4. 15 is bigger than 4. 15 is negative, so the answer is negative. 15 minus 4 is 11. And so there we have it in our slope-intercept form. There's our slope, there's our y-intercept. So we went from the slope formula to the point slope formula, from the point slope formula to the slope intercept formula. Now, how do we go to standard form? X and Y have to be on the same side. So I got to move the X to that side. So I subtract 5x from both sides. Negative 5x plus y equals negative 11. X and y on the same side. Is it in standard form? No. Look at the conditions. You have to have A has to be positive. Since A is negative, A is this first, whatever's in front of the X, that's A. Because it's negative, change all their signs. So we get positive 5x minus y equals positive 11. Now it's in standard form. So far, so good. So that's how we convert. In other words, you don't have to memorize the formulas. Just memorize the slope and how they relate. So in our sheet, let's look at example 1. In our sheet, it says this. A line has a slope of negative 7/9 and a y-intercept of 0.16. Find the equation of the line. Slope equals negative 7/9. The y-intercept equals 0.16. It wants us to find the equation of a line. So what do we do? This is the slope, that's m. And since that's 0, that means this is my b. There's my answer. So if you have an x value that's 0, that means this, if equal to 0, then this is your b value. Unlike example 2, which says our slope is negative 2/3 and contains a point negative 3.6. Find the equation of the line.
X is not 0 and it's negative 3. Does that matter, or will the 6 still be B?
No. That's this is different. If that's not 0, this is not B. So if not equal to 0, then not equal to B. So we have to find B. To find the EOL, if given the slope and a point that's not the y-intercept. Here are the steps. Write the equation of the line, the formula, which is y equals mx plus b. Plug in what you are, plug in what you're given. We're given the slope is negative 2/3, and we have a point, negative 3/6. So the m is the slope, so it's negative 2/3. What's in here? This is the x and that's the y. So my y is 6 and the x is negative 3. The only thing I don't have is b. Then solve for b. So the first thing we do is, can we simplify this? Negative times negative, they cancel, becomes positive. The 3's cancel. 3 goes into, so we have 6 equals 2 plus b. Subtract 2 from both sides. 6 minus 2 is 4. So we know b. We know our slope is negative 2/3. Plug m and b into y equals mx plus b. Our m is negative 2/3 x. And since b is positive, it's a positive 4. And there's my equation. You got a question? So if we're given a slope and a point, that's not the y-intercept, then we have to find the y-intercept. Okay, move on. Okay. Now, if we're given 2 points, then we got to do what? That's what example 3 is about. Given 2, 3, and 1, negative 4. These are 2 points on a line. Find the equation of the line. Because remember, to find the equation using these formulas, we need a point and a slope. My first step then, I'm given 2 points. Find the slope, first step. That's y2 minus y1 over x2 minus x1. I label my points x1, y1, x2, y2. So what's y2? -4. Minus y1 is 3. x2 is 1 minus 2. Negative, and they're both negative. 4 plus 3 is 7. This is positive, that's negative. 2 is bigger, so the bottom is negative. 2 minus 1 is 1. The two negatives cancel, so the slope is 7. So we found the slope. So now we have the slope and 2 points. So choose either point. Which point do you want to use? The first one or the second one? Yeah, because it has no negatives. And I use the point 2, 3. Plug into y equals mx plus b, because we're missing the b. And find b. So this is like the last question. We're given a slope and a point. So the y value is 3. The slope is 7. The x value is 2. And we don't know b. So this is x, and that's y. Seven times 2 is 14. Subtract 14 from both sides. 14 is bigger than 3. It's negative, so the answer is negative. 14 minus 3 is 11. So I have my slope. I have my slope there. Plug m and b into y equals mx plus b. So it's 7x minus 11. There's your equation of the line. Again, it all depends on what you're given. There's no one easy magic. You have to find stuff, but you have to get to a place where you know the slope and you know the y-intercept. If you don't know the y-intercept, use a point and then find it. Parallel versus perpendicular. To talk about this, I'm gonna first discuss because in order to have parallel and perpendicular lines, we need to have two lines. So if you have two lines, four things can happen. That's line 1 and line 2. That's line 1. That's line 2. That's line 1. That's line 2. And that's line 1. That's line 2. So if you have two lines, four things can happen. Remember, what is the solution? If you have one line, a solution is where it crosses the x-axis. If you have two lines, a solution is where they cross. If two lines, a solution is where they intersect. So if you have two lines, a solution is where they intersect, not the x-intercepts. So how many solutions in this first one? So we have no solutions. How many solutions in this bottom one? This one? Infinite. Yep, because every point is a solution. There's same line. Infinite solutions. So in these first two, it's either all or nothing. In these next two, there's only one solution. So we can tell what our solutions, what kind of solutions we're going to have if we understand our equations. What do you notice in this top left? What do you notice about those two lines? What can you tell me about them? Remember, the equation we're using for lines is y equals mx plus b. What can you tell me about this first pair? No, the cost should be going down, so that doesn't matter. They're parallel, but what tells us they're parallel? This is if you see a picture. If you have two equations, how can you tell if they're parallel? You're getting close. Well, let's pretend that this is our grid. They can both have x-intercepts. They both have y-intercepts. But what can you notice about them? What do you observe? There's two things we can observe. They all have, yeah. What about the slopes? If they're parallel, they never touch. So that means the slope of line 1 has to be exactly the same as slope of line 2. Because if you're on the highway and you're going the car next to you, you have the same direction, same slope. Because only if your slope changes, that's when the collision happens. So in the first one, the slopes are the same. What else can we notice? Well, if the slopes are the same, are their y-intercepts the same? No. Their y-intercepts have to be different. Because if they had the same slope and the same y-intercept, what would they be? That would be the same line. If the slopes are equal and the y-intercepts are equal, then they're the same line. They have an infinite number of points the same. Just here's our XY grid. They have the same y-intercept and they have the same slope. So it's either all or nothing here. Infinite solutions if they have the same everything. No solutions if they have the same slope, different y-intercepts. Now comes the big difference. Since these two are the only parts you can have with same slopes, these have to have different slopes. If slope 1 does not equal slope 2, then it's that. That's just the basic, there's no rhyme or reason. It's just they're not the same slopes. But this one is called a perpendicular. Two lines are perpendicular if they intersect and they create a corner, a right angle, 90-degree angle. That's what that little sign there means, 90 degrees. So two lines are perpendicular, and we don't look at the y-intercepts. You notice on this side, we don't care about the y-intercepts because this can be the y-intercept. They can cross at the y-intercept, so we don't look at that. Only thing we look at is the slope. If the slopes are different, we have one solution. Now, to be perpendicular, the slopes have to be negative reciprocals of each other. To be perpendicular, the slopes have to be opposite signs and they have to be flips of each other. Let's see what this means. Oh, we also have symbols. Instead of writing this stuff out, instead of writing parallel, we just write two short lines like that. And instead of writing perpendicular, we put it upside down T. That means perpendicular. I'm going to give you a slope. You give me the slopes of the lines parallel and the slope of the line perpendicular. What's the slope of the line parallel to that? Why is it 3? They're equal because to be parallel, they have to be equal slopes. So if that's 3, this one has to be 3. What's the perpendicular? It's going to be negative because that one's positive. What? 1/3. Because this is 3/1. It's got to be a flip of it. M equals negative 2/5. What's the slope parallel? Negative 2/5. Nope.
Wow.
Yeah, so this one, change sign. and flip. This one is the same. How about this one? Right. So what's the, very good. Why would it be undefined? Yeah, because right now it's 0/1. When I flip it, it's 1/0. You can't have that. So if I give you an undefined slope, what's the slope parallel to it? Because these have to be the same. Parallel has to be the same slope. And line perpendicular, because this one is 1/0. And I flip it, so it becomes 0/1. Determine whether the lines are parallel. This is example 4. If parallel or perpendicular or neither. We have two lines, y plus 2 equals 5x and 5y plus x equals -15. Are they parallel, perpendicular, or neither? Well, what's the only way we can compare them if we know what? The slopes. What formula does it have to be in to know the slope? It has to be in y equals mx plus b. Are these in y equals mx plus b? No. So that's the first thing, before you do anything, put it in that form. So this first one, I subtract 2. And the second one, I subtract the x. And then divide by 5. $15 divided by 5 is 3. So now we have the slope intercept form. Are these two lines parallel, perpendicular, or neither? Why? Right, because this is 5/1 and it's positive. If I flip it, I get 1/5 negative, right? So it's perpendicular. The slope of line 1 is 5. The slope of line 2 is -1/5. B, 2y plus 4x equals 8. And 5 plus two x equals negative y. Letter B. So solve for y. So we subtract 4x from both sides. 2y equals negative 4x plus 8. Divide by 2. Get the y by itself. So it's negative 4 divided by 2 is 2. 8 divided by 2 is 4. Change all the signs. So it's negative 5, negative 2x equals positive y. I can flip it. So the slope of this one is negative 2. The slope of this one is negative 2. What does that tell me? It's either parallel or the same line. The B is positive 4 here. The B is negative 5 here. So that means the two lines are parallel. To be parallel, you have to make sure you check both of those. The slopes have to be the same and the y-intercepts have to be different. And letter C. 2x plus 1 equals y. Y plus 3x equals 4. Flip them over. Subtract 3x. So the slope of the first one is 2. And the slope of the second is negative 3. So what does that tell us? Are they parallel? No, because they have to be the same. Are they perpendicular? Are the signs opposite? Yes. Are they flips of each other? No. So it's not perpendicular, it's not parallel. Neither. Once you get it solved for y equals, compare the slopes, whatever's in front of the x, and then look at the y-intercepts if the slopes are equal. Example 5. It says, write equations of lines A parallel to and perpendicular to the graph of the line 4y minus x equals 20, containing the point 2, negative 3. Okay. Write the equation of the line parallel and perpendicular to the line 4y minus x equals 20. Going through the point 2, negative 3. I'll give you all a few minutes to work on this. So what's the first thing you think we have to do? Exactly. We have to find the slope of what? Because remember, we're looking for lines that are parallel and perpendicular to this line. So we have to know everything about this line. So find the slope of the equation 4y minus x equals 20. Because we have to know what it's parallel or perpendicular to. Has to go through that. So solve for y. Because it has to be in the y equals mx plus b. And then divide by 4. Twenty divided by 4 is 5. So this is our equation. That equation has slope 1/4. So the slope of the line parallel is going to be what? 1/4. Parallel has to be the same. And then the slope of the line perpendicular is going to be -4. You have to change the sign and then flip it, which is -4, right? So far, so good. So now we have the slopes which needed, because we have the point right here. So we have the point 2, -3, 2, -3. We just have to find those two equations. So the slope parallel, the equation of the line parallel has a slope 1/4 going through the point 2, -3. 2, -3. Remember how we do that? So basically, all we have to do now, this is the stuff we need to be parallel. Whatever equation we get now will be parallel to the other equation. So how do we start this one? What's the equation of the line look like? Y equals mx plus b. That's the equation of the line form. Plug in what we know. This is x, that's y, and that's m. So we have -3 equals 1/4 times 2 plus b. We don't have b. These can reduce. 2 goes into 4. So we have -3 equals 1/2. Again, I'm gonna try to give you some hints to make it much easier for you. Whenever you have fractions and an equal sign, whenever you have fractions and an equal sign, get rid of the fractions. So first thing you do is find the LCD. What's the LCD in this equation? No. What's the LCD of this equation? That's what LCD stands for, but not for this equation. 2. It's the only denominator, right? It's the only denominator. Take the LCD is multiply the LCD to each term. So there's 1 term, there's 2 term, there's 3 terms. Multiply 2 to each one of those. Remember, a term is anything separated by a plus, minus, or equals. Third step. Reduce, simplify. Can anything cancel here? These cancel. Yeah, that's the whole reason we multiplied it, to get rid of it. So now we have 2 times -3 equals 1 plus 2 times b. Because the numbers 2's are gone, so we just have 2 goes into 2 once. 1 times 1 is 1. Multiply to remove parentheses. Positive times negative is negative. 2 times 3 is 6. 2 times b. And then solve. Subtract 1. Negative, they're both negatives, the answer negative. 6 plus 1 is 7. And divide by 2. So my b value is -7/2. And my slope was 1/4. So my equation of the line parallel is y equals mx plus b. 1/4 x minus 7/2. That's my answer. That's for the parallel. Now for the perpendicular. Equation of the line perpendicular is, I know my slope is -4. And it's going through the point 2, -3. Again, the equation of a line is y equals mx plus b. Plug in what we know. This is x and this is y. So -3 equals -4 times 2. Solve for b. Negative times positive is negative. 4 times 2 is 8. Add 8 to both sides. 8 is bigger than 3, it's positive, so 8 minus 3 is 5. So my y-intercept is at 5, my slope is -4, So my equation of the line perpendicular is negative 4x plus 5. That's how we figure it out. Any questions so far? That does it for section 4.